In this video, I'm going to explain Pauli's exclusion principle, which is a quantum mechanical principle. To understand it, we need to discuss the quantum numbers first. There are 4 quantum numbers: the principal quantum number, or n, the orbital quantum number, L, the magnetic quantum number, ml, and the magnetic spin quantum number, ms. N, which is energy level or shells in Bohr's model. So I write, and we have n equal 1, 2, 3. So I write n equal 1 here. Then we have n equal 2, n equal 3, and n equal 4 for the first 4 shells. Then if we want to find L for each shell, L shows the type of orbital that we have in each shell. And L can be calculated by doing L equal 0 to n minus 1. So as a result, if n equal 1, L is 0, and n minus 1 is 0. Just for n equal 1, just we have L equals 0. So I write for n equal 1, just we have 1L, that is 0. For n equal 2, it's the L that we have is 0, and then n minus 1 is 1. And we don't have any number in between. For n equals 3, L equals 0, and n minus 1 is 2. So the number between these is 1. And for this one, we have 0, 1, 2, 3. What does it mean? It means for shell number 1, we have 1 type of orbital. Shell number 2, we have 2 types of orbital, and 3 and 4. L equals 0, we name it orbital type S. So all zeros are S, that they are spherical. And shell number L equal 1 is P. So the type of orbital, we name it P. 2 is D. And 3 is F. So far we know in each shell how many types of orbital we have, but still we don't know how many S orbital we have, how many P, D, or F. That we can find it using ML. ML showing that equals negative L plus L. So if L equals 0 for orbital S, it means ML can be only 0. So it means for orbital S, just we have 1 orbital. But if L is equal 1, it means ML can be from negative 1 to positive 1. That is 0 in between. It means we know L1 is P, so it means we have 3 types of P orbital that we name it Px, Py, and Pz. So I write it here for S, so we have only 1 orbital. And for each orbital, I show it using a small square. And for N2, we have S that has only 1 orbital. And always P has more energy than S. And we have 3 P orbital. So, but the 3p orbitals have same amount of energy. So I showed it 3 orbital. Without any gap between them, that means their energy, they have equal amount of energy. And here we have S, 3p, that they have same amount of energy. And if we calculate ML for 2, it's from -2 to +2, that is 5 orbital. Thus I write here L2, ML is from -2 to +2, so it becomes -1, 0, 1, and 5. And same things here again, S, P, D, and F with 7 orbital. 1, 2, 3, 4, 5, and 6, and 7. So each orbital can have 2 electrons inside, but there is a problem now. If I have 2 negative electrons, and I want to put 2 electrons in one orbital, but 2 negative charge particles, they repel each other. But we have ms, the next quantum number, that it can have the number of +12 or -12. And it shows the direction of spinning of electrons. And as we know, electrons are charged particles. And a mobile charged particle makes a magnetic field around it. So as a result, if we have 2 electrons that they are spinning in opposite direction, it means we have electrons, 2 electrons, one spinning this direction, one spinning opposite direction. Definitely, because they are negative, they repel each other, but because they are spinning in opposite direction, if this side is N, this one is S, this one becomes S and N. So N and S attract each other, so we have repulsion because of same charges, and we have attraction because of opposite poles. So as a result, by doing that, we can put 2 electrons in one orbital. So we can put electron 1, and we show it with arrows in opposite direction. And we put electron. But what's Pauli exclusion principle? Pauli exclusion principle states that we can't find 2 electrons in an atom which all their 4 quantum numbers are the same. Why? Because if we have 3 quantum numbers the same, it means N similar, L similar, and ML similar. It means 2 electrons are in one orbital. And in one orbital, definitely their ms should be different. So also we need to remember always when we put electrons, we start from the lowest energy level. So this one need to be filled with electron. The next electron can go here. And when we start putting electron here, I can put 1, 2, 3. Because they have same amount of energy at the same energy level. Firstly, I need to put 1 electron in each orbital, and then after that, I can start pairing electrons like this. And we can continue filling every single shell. Using that, we can write electron configuration for different elements. I hope you found this video helpful, and thank you for watching.